Hey guys, thanks for having me. I am with a company called Azul. We help make a really fast, really secure Java virtual machine. So for anyone who's out there in your audience who either writes Java applications as a software developer or runs Java applications, let's say you're a system administrator, Azul helps provide you with a drop-in replacement for any Java virtual machine that you are using today that is really fast and is easier to secure. So if you need to decrease your cost of compute or improve the latency and speed of your applications, Azul has a really nice software for you in the Java space. My name is Erik Costlow. I'm on the product management team for Azul, and I've been working in the field of Java security for about over a decade now. So I've seen quite a few ways that people can break into Java applications. Right. So when you hear people talk about the software supply chain, especially as we talk about Java applications, I want to clarify what the supply chain means. And for the most part, it means software that you get from someone else, whether that's a complete application that you purchase from a vendor or the libraries that make up your own software that you're developing. And regardless of those, whether you're buying it from a vendor or whether you're building it, for a lot of applications, a large majority of what makes up those applications comes from open source software. And these are the components that you download from Apache, from Maven. They're all of the libraries and capabilities that make it possible for us to build software. And software has been vulnerable for a significant amount of time, but I think there has been a shift towards vulnerable libraries that get incorporated to software. And one of the reasons is that the hackers work like businesses also. They want to attack software systems and be able to break into things that scale just the same that companies want solutions that scale. So recognizing that if a hacker goes after an application, that application, they're limited by the number of users of that application. But if they figure out how to attack a library that's present in many applications, then they have a much wider threat landscape to be able to compromise. Now, also on the defensive side, it's really difficult for a lot of people, this is your IT infrastructure, your operators, to figure out where those tiny components are. Well, one of the reasons that IT teams can't update their systems fast enough to patch those loopholes is that often when the vulnerability is inside of a library, it's really hard to figure out where exactly that library is. So you take log4j as an example. That happened last December. There was a survey that went around that a lot of people spent more than a month remediating that vulnerability. Now, if you're technically inclined and you work on an individual system, you know that the fix is actually quite easy. You replace a library. But imagine that problem spread across thousands of applications on thousands of hosts, each of which you only have limited visibility at. The difficulty is not the ability to patch a loophole. The difficulty is figuring out where to actually look. For a lot of companies, they know that some of their software is in Java, but if you ask a question like, which of your pieces of software are in Java, they tend not to know. Now, imagine asking now, of the Java software that you run, which of those components contains the vulnerable version of log4j? It's not that they spent the time patching the loophole, it's that they spent all that time figuring out where the loophole even was. Yeah, so do your average IT administrator, either a cloud ops or a system administrator, do they have good visibility into the nuts and bolts of their system? Sometimes they do, sometimes they don't. For a lot of cases, there's a drive in the industry now towards something called an SBOM. That is a software bill of materials, and that's just creating a list of what components make up that piece of software. And the reason that SBOMs are important is that when a new vulnerable library is discovered, it's much easier if you can consult a list of where those components are, because now you know where to look. But one of the problems with SBOMs is that, first of all, there's no real requirement that they're accurate, so people can give you an SBOM that leaves out components. Also, there tend to be gating controls, like you look at one area on a path, but software makes it to production through a variety of means. But most importantly, this isn't really work that I think teams should be doing. So the question is not, is it possible to have good visibility, but should the people who work on the systems be focused on that problem? And I would say that the software itself should be giving us that inventory of what it has, because the software knows the APIs. If I encounter an application that I've never written because I'm just told to run it, I have no idea what those libraries are. I have no idea what API it calls. And, I might know the permissions, but I'm only going to know that by asking people. But the software knows it. So what Azul is doing with the new vulnerability detection product is to make it so that the software inventories itself through the act of running. So the administrator or the IT team doesn't have to go out and get good visibility into software. The software gives them good visibility simply by running. So it's much easier and there's a lot less work. Right. So how often do I have to update my defenses, and do I constantly have to be better than the hackers or the different people who might want to break into my organization? It is really difficult to constantly stay ahead of those people, but a lot of what we can do is to break it down into what's the simple action that we can do. The easiest thing that we can do in order to keep a lot of hackers out is to focus on updating software so that when something has a known vulnerability, that we remove that as fast as we can. What happened in the past, one of the reasons that a lot of this was difficult was that vulnerable software would just be kind of left there. So hackers could just go to various exploit databases, download some payloads, and then break into a lot of software. So setting up defenses and being fast enough is not always about updating a really powerful, really complex defense. Sometimes it's just about updating the software that we have and making sure that we're not running known vulnerabilities. All right, thank you very much for having me.